Hello, everyone. Welcome to IGCSE Physics 0625 lessons with Mr. Daler Haidaro, or shortly Mr. Daler. So, if you are ready, let's continue with our next lesson. So, we are in chapter 13 about light. Today's lesson is about refraction of the light. So make sure you have everything ready to take notes, your exercise book or notebook. Put down, start with the date, then the topic. So if you're ready, let's continue and let's start with a interesting question. Now, let's have a look at these interesting pictures, distorted ones, right? In one picture, you can see the image of the duck floating on the water. So as you see, the camera is taking from a perspective of water to air, so somewhere in between, I guess. And then half of the duck is distorted, moved. And then second picture, as you can see, broken pen. So what might be the reason? The answer lies to the topic of the lesson today. It is about the refraction. Now let's see what is refraction is about. What are the other examples, how it happens, and what are the uses or applications of refraction in our real life. So we're going to discover and understand all these questions throughout this lesson and next lessons about the refraction of the light. So to begin with, if you look down, have a look at this another picture here. This is another example for the refraction of light. So what do we see? Uh, some ripples on the bottom of the pool, and then as we know, if you look down to the bottom of the swimming pool, you might see this pattern of shadowy ripples, as you can see on this figure. So we know that the surface of the water is not flat, right? That's why there are often small ripples on the water, and this cause the rays of sunlight to change the direction. So some parts at the bottom of the pool you'll see brighter, some parts are darker. Where the pattern is darker, rays of light have been bent away, uh, producing some sort of shadow. So what does this tell us about this bending of rays of light when passing from one medium into another is called refraction shortly. So this is the result of refraction here. Uh, so make sure you pause the video and then take notes. So let's continue then. Uh, so there are many effects caused by the refraction of light. Some examples, not limited to, some examples would be sparkling of diamonds, the way the lens in your eye produces an image of the world around you, and the twinkling of the stars in the night sky. And lastly, the image of the bent straw in the liquid, as you can see in the figure. So these are the some of the examples for the refraction of light, and they are very interesting, right? So look at the picture, the bent image of the straw. Uh, in reality, it is not bent, it is not broken, right? So you can test it at home actually, or you have seen it before. You can take it out and see. Now, let's continue. Let me continue, but make sure you pause and take good notes here. So this is another example for the refraction. As you can see, a beam of green light from the laser is going from the air and passing into the water. When passing, as you can see, it is clearly changing the direction. So what is happening? This is a good example for the refraction. Let's continue now. Let's answer how it occurs, right? Or let's analyze the causes and some other terms related. So it occurs when the ray of light travels from one medium into another. Of course, these media are transparent media. not air and a block, air and wall. No, from air to glass or from air to water or vice versa. So the ray of light may change the direction, right? It will change the direction when it passes from one medium into another. This happens, the refraction happens at the boundary of two media. The ray approaching from the boundary is called the incident ray. The ray leaving the boundary would be, as you might guess, refracted ray. Yes, analyze the drawing here and make sure you have this drawing on your notes. The angle between the incident ray and the normal line would be what? Angle of incidence. The angle between the normal line and the refracted ray would be angle of refraction. What is normal line? Remember, we have discussed this before. Normal means perpendicular or 90 degrees. We draw normal line to the point where incident ray hits the boundary. Yes. Make sure your normal ray comes and intersects that point, not somewhere else. Anyways, so please draw this diagram. Make sure all the terms are clear. Another key word here would be the angle of refraction. So find all these details on page 273 of your course book. Let me continue now. Let's demonstrate and let's see a real life image or picture of refraction now. So the direction in which the ray bends, of course, would depend on whether it is entering or leaving some medium. For example, for this case, we have a block of a glass block. As you can clearly see, a ray of light is coming, entering, and then bending clearly. A little part of it might be reflecting. That's not important for now. And then again, when leaving the glass, it's again bending. So here we would be saying ray bends towards the normal when entering the glass, as you can see, and ray would be bent away from the normal when leaving the glass. Let me demonstrate it in next slide. Don't rush to take notes. Let's write from next slide. Here, first case is when light ray comes from air to another transparent medium. In this case, as you can see clearly from this picture drawing, the ray of light bends away from the original direction. Okay, I hope this is clear. So light ray bends towards the normal when entering from air into a transparent material. Okay, second case, light ray will bend away from the normal or from its initial direction when it goes from some material like water or glass into air. Okay, so this is the second case. And I hope this is clear. And case number 3, what happens now when the light comes straight at 90 degrees or perpendicular to some material, like the one here is shown. Then ray hits the boundary at 90 degrees, it won't be refracted. It will just pass. Okay. Now, let me continue with the last slide. Now let's try to explain the refraction. Why refraction happens, right? So why refraction happens? Now, to understand why refraction happens, my friends, the simple answer would be light travels at different speeds in different media. Light is refracted because it travels at different speeds in different materials. It travels fastest in vacuum and in air, but it gets slower when it enters water, glass, diamond, or other transparent substances. So there is analogy here which can clearly explain why refraction happens. Analogy is about the truck leaving the concrete road into a sad or muddy road. But here I will pause and pass to a short movie. It's about 4 or 5 minutes in length. It will clearly explain the concept of refraction, how refraction happens, and why happens. So please watch in next slide. Or if you want to take notes and understand it fully, please check page 239 of your course book. Uh, there are two in it's explained in two paragraphs there. You will find this image of truck there. Now let's watch from this short, interesting movie on the next slide.
If you look from above at a pencil that's partially submerged in water, you see that the part that's underwater looks kind of bent or misshapen. Remember that you see any object because light waves are coming off that object and reaching your eye. But those light waves behave differently in different materials. They travel faster or slower depending on the material. Light travels faster through air than it does through water or plastic. So when light travelling through air reaches a plastic block, for example, it slows down. To understand why the pen looks weird through water, let's forget about light for a second and picture a car travelling along a road surface, then reaching a patch of sand. Just like the light wave, the car slows down as it reaches a different material. But now imagine the car reaches the sand at an angle. As the first wheel reaches the sand, it slows down. But for a short period of time, the other wheels continue at a faster speed. Because the wheel on one side is going slower, the whole car turns slightly. Once the whole car is on the sand, it continues in a straight line, but not the same straight line that it was travelling on along the road. Light rays work in the same way. If light rays are moving through air and reach a different material at an angle, they'll change direction slightly. This is a ray box that we often use for light experiments. And this cover lets us beam a narrow ray of light from the bulb. If I aim the beam at the plastic block at an angle and turn the other lights in the room off, you can see the light beam is bent as it enters the plastic, and again as it exits. This happens just like the car reaching the sand. The speed of the light ray decreases as it reaches the plastic block, but then speeds up again as it exits the block. This bending of light is known as refraction. We can say that the light is refracted. Let's consider some of the details of what we're observing. First, you need to understand the word normal. Normal is a word that comes from Latin meaning at a right angle. The normal is an imaginary line at a right angle to a surface. Looking at the ray box setup, here you can see the normal drawn at a right angle to the surface of the plastic block. And when we talk about angles of reflection and refraction, we describe them relative to this line. Here, the ray, known as the incident ray, reaches the plastic block at 45 degrees from the normal. This is the angle of incidence. The ray within the block, known as the refracted ray, moves through the plastic block at 30 degrees from the normal. This is called the angle of refraction. Because the light then exits the plastic block and returns to air, it speeds up. The emergent ray exits the plastic block at the same angle as the incident ray. In a case like this, the incident ray and the emergent ray will always be parallel to each other. So how does refraction affect how we see the pencil in water? Well, light reflected off the pencil moves away from the pencil through water, and it's refracted as it travels between water and air. It speeds up when exiting the water, bending away from the normal before reaching your eyes. Your brain assumes that light travels in straight lines, so it looks like the pencil has been bent to reach the point where you think the light beam has come from. It's because of refraction that we're able to focus on things using lenses. As a light ray reaches this lens, the ray is refracted toward the normal. Then, when leaving the lens, it is refracted away from the normal. Because of the shape of the lens, all of the emergent rays are refracted towards each other, focusing at a single point called the focal point. This is called a convex lens, sometimes known as a converging lens, because the light rays converge as a result of going through the lens. It's this type of lens that we have in our eyes that allow us to focus light from objects onto our retina, so we can see a clear image.
That's it. Thank you. So you can find this video. Thank you for this guy. This very interesting video about the refraction. Here we come to the end of our lesson here. Make sure you have good summary notes about the refraction. And now check page 239, question 7 to 10. Please answer them. And in addition, check question 3 at the back end of your chapter. Question 3 here. Make sure you have answered them. As an optional homework, give you homework. Please do these past paper questions. Question 1, 2 here, and then question 3. There are 3 questions here. So thank you very much for joining me this lesson. That's all. See you next time. Bye bye.